Hi everyone and welcome to my presentation for the PhD Poster Day 2020. My name is Dena Markudova and I'm just finishing my first year of PhD here at Politecnico di Torino at the Department of Electronics and Telecommunications and the Interdepartmental Center Smart Data. My mentor is Professor Michela Meo. So what is my research about? Well, my main project is with Cisco and friends and it's on real-time communications. In 2020, we saw how important these applications are when we were left at their mercy for work and leisure during the coronavirus crisis. So we feel that better quality of experience is needed here. But this has to start at the network level. So in the project, we want to encourage network management policies that favor QoE of online meeting applications. So what are the research questions or problems that we are trying to solve? Well, first, if we want to act on real-time traffic, we need to find it in our traffic mix. What a normal sniffer would see is UDP traffic. Then we want to find out if this traffic is RTP or not. Wireshark can do that, but sometimes it falls short. Then we want to know if the traffic was generated by meeting software or not, and if yes, which was exactly the meeting software that was being used. And we also want to know what was the type of media that was being exchanged, because maybe in the future we can prioritize some of these flows. In this presentation, due to time, I will only talk about what is the meeting application problem. So what are the novel contributions here? Well, with the spread of encryption, network traffic classification using machine learning starts to overcome the traditional deep packet inspection techniques. So what we aim to do here is to develop a comprehensive traffic management system that sheds light to the network plane on what is going on with real-time traffic inside the network. Are there any meetings going on? How many? How many participants? Who is the speaker? What is the perceived quality of experience? What is the application that is being used? And so on. As I said in this presentation, we focus on unveiling the application behind the RTC traffic. And how we do it is by using the domain names that are contacted prior to the start of the call. This makes our approach work in real time. So to this end, we devise a methodology and try it on a case study with 200 real calls from 5 meeting applications. What we do is we take these calls, we extract the TLS domain names contacted delta t seconds before the call starts, so the longer delta t, the more domains we let in, and then we transform this into a term frequency inverse document frequency feature matrix. This is a natural language processing techniques, which basically says that the importance of each domain depends on how many times it appeared in that call and how many times it appears throughout all the calls. Then we employ a 1 versus rest classifier, which basically we make 5 classifiers for each meeting applications, which are binary, and they are like Skype versus other, Microsoft Teams versus other. This gives us interpretability and robustness. Then each of these binary classifiers, we try one of these 5 algorithms: decision tree, random forest, k-nearest neighbor, support vector machine, and Gaussian naive Bayes. So what are the results that we get? Here we have a confusion matrix of the best performing algorithm, which is a random forest with as little as 100 trees that lets in domains that appeared in at least 3% of the documents with a delta t of 25, so lets in domains from 25 seconds before. What we can see are excellent results. We have an overall accuracy of 87%, and the only application with a lower precision is WebEx Teams, which means a lot of the applications are being confused with it. This may be due to background noise in the data collection, because maybe when we were doing calls with Jitsi, we had the application WebEx Teams open in the background. So how sensitive is our system to parameters? Here we can see a plot of a combination of the algorithms and delta t. So what we can see is that the larger the delta t, which means the more domains collected, the better is the performance. And we can see that the algorithms, well, they have more or less similar performance with the exception of KNN. And the best performance is reached with the random forest for 25 seconds before delta t. As future work, first we would like to try to guess the meeting application using statistical features of the traffic instead of the domain names, in case the header of TLS gets encrypted at some point or TLS becomes obsolete. Then we would also like to try clustering instead of classification for distinguishing the type of media, as an approach that doesn't require a lot of data. We would also like to try to find out the type of meeting only by seeing the network traffic mix. Thank you very much for watching, and I'll see you at the evaluation. Goodbye.